In this video, we're going to be looking at how to find all the real and complex zeros of a polynomial by graphing and doing a couple of other techniques. But first, we need to understand what we mean by real and complex zeros. So it's important that we talk about this idea of like a family tree of numbers. First off, all numbers can be classified under this broad category of being a complex number. And so in your notes, so maybe on a separate sheet of paper, if you can find a spot where you can write this down, we're going to write this family tree. And again, the broadest category is complex numbers. Now, from complex numbers, we have what you started out learning as a child. It could be categorized as a real number. Like if I were to ask you to think of a number, any number you'd give me would probably be a real number. Okay, and so basically real numbers are numbers that could be found on the x-axis. So any point that we could find on the x-axis could be classified as a real number. But what's our other category? We learned this year so far, we've talked about non-real numbers. So those would be our imaginary numbers. So if we were to zoom out a little bit here, we would see these first two categories in our family tree of complex numbers. So any number can be, so complex numbers, again, is a broad category. Any number that you could put on the x-axis, that you could graph on the x-axis, would be considered a real number, and a non-real number does not show up on the x-axis because those are imaginary numbers. Now, underneath real numbers, we have two separate categories of numbers, and those would be rational numbers and irrational numbers. Again, these would both be found on the x-axis if you were to graph them. But a rational number can be written as a fraction. So we can call those fractional numbers. And so any number, even like an integer, like 5, could be written as a fraction, 5 over 1, like 1/3, 13/5. Any number you can, negative 13/5, any number you could write as a fraction, we could classify as a rational number. And then we have another category of numbers that again would be found on the x-axis, but they're irrational. And these are numbers that can't be written as fractions, like square root of 2. When I say can't be written as a fractions, that means that with the real number in the numerator and the denominator. So pi would be an irrational number. Square root of 2 would be an irrational number. Again, these would be numbers too when you find them as a decimal. They're non-terminating, non-repeating decimals. Okay, so there's not going to be any pattern. It's just a continuous decimal that would go on forever. And so there are other categories of numbers, but these are the key ones. And the reason why these are so important to understand is because this is going to help us with the next thing that we're going to be learning about, and that's finding all the zeros or roots of a polynomial. So again, I want you to write this down because the degree of a polynomial is significant. We've talked about that before. Not only can we use the leading term and its degree to figure out the end behavior, but the degree of a polynomial, when it's written in standard form, again, if it's in factored form, we need to figure out what the degree would be if it was in standard form. But the degree of the polynomial in standard form indicates the total number of zeros, both real and non-real. So let's look at this example. So again, pause the video if you need to so you can get this all written down. So let's look at this first example. We have, this is not in your notes, by the way. This is separate. So we have f of x equals x cubed plus 5x squared plus 2x minus 8. So using this rule that we just said, the degree gives us a total number of zeros. So the degree of this polynomial would be 3. So I know that this function should have 3 zeros. And that means some of those zeros will show up on the x-axis, some of them might not. So we want to figure out total number of zeros. So total number of zeros will refer to, or the total number of solutions, I would refer to this idea of the complex numbers. So some of those might be real, some of those might be non-real. Some of those might be rational, some of them might be irrational. But let's look to see how we can figure that out. Let's say if we were to graph this. So again, if you were to pause this video, you could go to your graphing calculator and you could type this in. Remember to get the X button, go to this alpha, just to the right of the alpha button, we have your X button. To do cubic, we would have to use a caret and then 3, but remember then you have to move your cursor down. If you're wondering what window settings I'm using, these are the window settings I have, so you can pause the video, get your calculator all set up, and then graph this, or just look here because this is really what I want you to see. Is the fact that this graph, you see that the degree was 3, and turns out we have 3 x-intercepts. Okay. Now let's say I were to use the same equation. Let's say if instead of minus 8, Let's say if I were to change this equation slightly just to move the graph up or down. So let's say if I wanted to change this. So again, we're going to keep it with the degree of 3, but I'm going to change this instead to be -8, I'm going to have it be -13. So this is just going to move it down 5 spots. So now let's look at the graph. So again, the degree is 3, so there's a total of 3 zeros here. But there's only one x-intercept. So that means the other 2 zeros, since they don't touch the x-axis, the other 2 zeros, if they don't touch the x-axis, are going to be non-real solutions. Well, how do we figure that out? Well, that's going to be the purpose of the rest of our video here. So just know that a lot of your problems in your homework assignment, you're just going to look at the graph. And remember, you can find the x-intercepts. Like let's say if I wanted to figure out what this x-intercept is, because now this looks like it's a decimal value. And to find out what that decimal value would be, we would do second trace, and then we would find the 0, and we would move our cursor somewhere to the left of that x-intercept, hit enter, move the cursor to the right of that x-intercept, hit enter one more time. We can see again, this is probably an irrational number, but the 0 here would be 1.3. So if we have x-intercepts, that's one way that we can find what the values of those x-intercepts would be. Well, let's see if we can figure out how we can figure out the values. When we're just looking at an equation, how we can find what the complex zeros would be. So let's go back to our notes. All right, so here's one. Or again, if you were to graph this, so in your assignment today, you'll have to do the graphing on your own. But we're not going to waste your time with that because we've done enough graphing right now. So you should be familiar with how to graph. So if we were to graph this, how can we figure out what all the zeros are? Well, there's going to be a process. Let's write those steps over here. So the first step is you're going to find the real zeros. So by finding the real zeros, that means we're going to look for the x-intercepts. The next step is we're going to use the real zeros and synthetic division. Because our goal is to get a quadratic. Okay, so our goal is to change this cubic function to get a quadratic. So the way that we're going to do that is we're going to use the 0. So the 0 here is 2. And we're working with this polynomial. So remember, we write down the leading, or the coefficients for each term. So we have a 1, a 1, a -3, and a -6. Remember, if there's any term that's missing, we need to fill that term in with a 0. So if there hadn't been an x squared here, we put a 0 in there for 0x squared. Let me erase that. All right, so remember, for setting this up, we want to put a box down here. Remember, this represents the remainder. Now I know that this is a 0, so my remainder should be 0. If I don't get 0 as my answer, I did something wrong. So remember, there's nothing to add to the 1, so I just carry that down. Remember, the process now is I take that 0, which is 2 times 1, and I get 2. Add these together, I get 3. 2 times 3 is 6. Add those together, -3 plus 6 is a +3. 2 times 3 is a +6 again, and -6 plus 6 is 0. So again, we wanted to have a 0 there. All right, so now remember, we're trying to get this into a quadratic. So remember, this stays your constant. And then we just put in our x's. So we would have x squared plus 3x plus 3. And now we're trying to find the zeros. Okay, so we would set this equal to 0 and solve it. Now remember, we have some different tools we could use. We could use factoring, but I know this isn't going to be factorable. How do I know it's not factorable? Because there are no x-intercepts here for this part of the equation. So the only way to solve this, and if you wanted to, you could try to factor that down, and you'll see that it doesn't. So then if that doesn't work, the next step is we are gonna do step 3 over here. If it can't factor, we want to solve the quadratic. And to do that, we're going to use a quadratic formula. If you can't remember the quadratic formula, let's write that down. X equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. All right, so let's look to see where we left off at. So again, this x squared plus 3x plus 3, that can't factor. So I'm going to set this equal to 0 and solve it by using the quadratic formula. So I would have x equals the opposite of b, so negative 3, plus or minus the square root of b squared, so 3 squared is 9. Oops. Sorry, can't talk and write at the same time apparently. So 3 squared is 9. Then minus 4 times a, which is 1, times c, which is 3. And all of that's divided by 2a, and 2 times 1 would just be 2. All right, so let's find the discriminant. Remember, the discriminant is a piece that's inside the radical here. And so 9 minus 4 times 1 times 3. Just type that in on your calculator. When you type that in on your calculator, we get negative 3 as your answer. So remember, the way that we're going to simplify that is we can take out an I, and that would make this positive. And the square root of 3 you can't simplify. So we would just say that our other zeros are negative 3 plus or minus I times the square root of 3 divided by 2. And so remember, we said that the degree will tell us all of the zeros. So the other zero, let me actually do this. The other zero is that x-intercept that we had at the beginning. So the zeros would be 2, and then negative 3 plus I squared root of 3 over 2, and negative 3 minus I squared root of 3 over 2, which is a total of 3 zeros. All right, let's look at another one together. So with this one, it says, what are all the real and complex zeros of the polynomial? So again, your first step would be to graph this polynomial. So when we graph it, we see that this time we have an x-intercept of 3. So I'm just going to write this up here. So I know one of our answers is that it's going to be 3. So we've got to figure out, well, what are the other two zeros? So we're going to use synthetic division. All right, so for synthetic division, we start with our 0, which is 3. And then our coefficients, all of them are represented, so we don't have to put a 0 in here. So we just have 2, negative 8, 9, and negative 9. All right, so there's nothing to add to the 2, so I bring that down, so that would just be 2. So 3 times 2 is 6. Negative 8 plus 6 would be negative 2. 3 times negative 2 is negative 6. 9 plus negative 6 would be 3. 3 times 3 is 9. Negative 9 plus 9 would be 0. So again, that should be your goal. So starting with 3 being your constant, this would be an x, this would be an x squared. So now we have our quadratic, so our quadratic would be 2x squared minus 2x plus 3. Again, if we set that equal to 0 now to figure out what the zeros would be, we could use a quadratic formula. So I would say x equals opposite of b. So b this time is a negative 2. So the opposite of negative 2 is a positive 2. Plus or minus the square root of b squared. So when you square negative 2, it becomes a positive 4. Minus 4 times a, which is 2, times c, which is 3. All of that divided by 2a. 2 times 2 is 4. All right, so now this time when we go to simplify and find the discriminant, we get negative 20. So remember, to make that positive, we would factor out an I. So now we'd have I square root of 20. So remember, we have to simplify this root. Before we do any simplifying with the fraction, we want to simplify the root. And if you forgot how to simplify roots, one way to do that would be to do a factor tree. 20 breaks down to be 4 times 5. 4 breaks down to be 2 times 2. 2's are prime, 5's prime. So for every 2 of the same number, we get to take 1 out. So what that means is that those pair of 2's come out, and that 5 would stay under the radical. So that's how we can simplify a radical there. Now, what's outside of there? All of those are divisible by 2. So there's 2 ways you could write your answer. One way would be to just take everything and divide it by 2. And so we would have 1 plus or minus 1i, or just I squared of 5, all divided by 2. Or if you wanted to, you could break it up as two separate fractions. So we could say 1/2 plus or minus I squared of 5 over 2, your other two zeros. So you could write it either way. I'd accept either one, but those would be your three zeros. All right, let's look at this last one. Well, this one's a little different. Notice how this one has a degree of 4. So our final answer for this one should have a total of 4 zeros. Now we can see from the graph, we can see two of them. We have a 0 at -2 and we have a 0 at +2. Now this one's going to require a little bit more work because remember, we want to get in step 2 there, what's in green, we want to solve it to get it down to a quadratic. Watch what happens when I do this synthetic division the first time with, we could start with either one. If you're wondering which one do we use, we're going to end up needing to use both of these, and you'll see why in a second. So it doesn't matter which one we start out with. Let's start with -2. So remember, we need to look to see, are we missing any terms? I'm missing a x cubed term, and I'm missing an x term. So we've got to put zeros in for both of those. So we would have coefficients of 1 for the x to the 4th, and then a 0 for the x cubed, a -3 for the x squared, a 0 for just the plain old x, and a -4. All right, so let's bring down, I have nothing to add to the 1, so we bring that down. -2 times 1 is -2. When we add those together, we get -2. -2 times -2 is a +4. We add those together, we get a +1. -2 times 1 is -2. Add those together, we get -2. -2 times -2 is a +4, and good, we got 0. All right, now the problem is, if I set this up as a polynomial, now we, whoops. I can't write and talk at the same time. If I set this up as a polynomial, I end up with a cubic, and I can't use a quadratic formula on a cubic. So before I put in those variables, or even after you put those variables in, we're going to have to use synthetic division one more time. But this time, we're going to use whichever 0 we didn't use the first time. So this time, I already used -2. So this time I'm going to use +2. But what we're going to do is we're going to just rewrite this answer that I just got. Okay, so we don't reuse the beginning, because otherwise we'd end up with, again, 4 terms. Our goal is to break this down smaller. So we're going to take the answer that we just got and factor this down further. So we're going to replace or reuse those answers that we got from when I used -2 in synthetic division. All right, so now we're going to repeat the process, like I said, using 2 as my 0 this time. So we're going to add 1 to nothing, so we get 1. 2 times 1 is 2. Now -2 plus 2 is 0. 2 times 0 is 0. 1 plus 0 is 1. 2 times 1 is 2. We get 0 as our answer. So remember, that 1 is a constant. This would be an x. This would be an x squared. So now I have x squared plus 1. Now I could set that equal to 0, and I could use a quadratic formula. Otherwise, if there's ever just a single variable, it's really easy just to solve it. So I would subtract 1 from both sides, so I get x squared equals -1. And if I take the square root of both sides, remember I have two solutions, plus or minus the square root of -1. If you remember, the square root of -1 is I. So we get our solution, our plus or minus I. So remember at the beginning, we said that there was going to be 4 zeros for this one. So we would have -2, +2, and then I, and -I, or we could have said plus or minus I. So those would be your 4 zeros for that polynomial. So that's it. So remember, in essence, if we see the degree of the polynomial is 4, like let's say if, going back to this problem, if this had been the x-axis instead, we would see that, yep, there's 4 x-intercepts, so we would graph it, we'd find those 4 x-intercepts, and those would be my 4 zeros. We wouldn't have to do all the work that we just did. The only time that we have to do all this work that we did with synthetic division is when the number of x-intercepts do not match up with the degree of the polynomial. Okay, so here we had 2 x-intercepts, the degree is 4, so that means the other 2 zeros would be non-real solutions, and so we have to figure out what those non-real solutions would be by using synthetic division and the quadratic formula. So that's it. So good luck now as you work on your assignment.